I'm Mathieu from Yelp, and today I'm going to tell you how we watch TV at work. I'll first go through a little overview of Yelp organization, how we are organized within the company. Then I will explain you the history, how we build dashboards for monitoring our infrastructure, and how we expanded this to service-oriented architectures and so to many teams. First, some numbers about Yelp and facts. So you probably all know Yelp here. So that's more than 30 million businesses review for businesses, and more than 112 million mobile users every month. So yeah, that's a nice infrastructure to keep running. So my role at Yelp, so I'm a site reliability engineer for almost 2 years now. Part of operation team, started in London and recently moved to San Francisco. So basically, my job is to make the site running. If it doesn't work, then it's my fault. So how are we organized at Yelp? We have, in engineering, we can say we have like two big families. The first one is infrastructure operation, which I'm part of, release engineering, metrics, DBA. We basically provide tools for the developer to work on. We just provide a platform and we maintain it. And then the people who are actually doing the work, like building the site, are organized into feature teams. What do we like to monitor as an infrastructure team? Well, you know, sometimes it's good to know what's happening at your edge. Like, oh, which CDN I'm using right now? Or where is my traffic? Is it in US West? Is it in US East? Is it not working? Is the main app broken? What's the current percentage of use of our data center? Or are we sending a lot of errors right now? So that's the kind of stuff we like to monitor. For that, we use SignalFX. So my talk today will be mostly about SignalFX. This is an example of a dashboard that we use to see both the usage of our data center and our traffic repartition. You can see the number of the left, percentage of the global traffic per region. Another example, the little one top right, that's the current usage of the nodes in our PaaS. So our platform is called Pasta. We build it ourselves, and our customers are the feature team that run the service on it. So this is a cool example of the heat map. Finally, another dashboard that we use a lot shows up the type of traffic per region. So here you can see 4 different active region or data center, because we kind of have like an hybrid architecture. And you can see, oh, the blue will be like mobile, while the purple will be like the search engine. The green would be the number of requests from browser, like this kind of metrics. And I'll come back on this one a little bit later. You'll see when we send errors, it's beautiful, dashboard-wise. Finally, the number at the bottom, we're using dual CDN. Like most, you know, when you have a vendor, it's always good to have backup. So these numbers just give us an indication, oh, which one are we running on right now? We also use Splunk a lot. Splunk is for different use case, though. It's more for data analytics. We go way deeper into the application stack, and the feature team use it a lot. So I'm not going to cover the Splunk usage on this talk. I'm mostly going to stay on like the metric real-time dashboard part of it. So dashboard are for people. I think they fill the gap between this little IRC channel that you can go and you see every single event that's currently happening. Don't go there. It's scary, especially if you like everything to be green. Everything is not green. Like, there are a lot of things in a critical state right now, but you don't want to see it. It's way too chatty. Second one, PagerDuty. When you get page, it's usually important. It's critical. There is an action to do. You need to fix things. I think the dashboard kind of sit in the middle of that. So, what do we see on dashboards? Well, first of all, when everything's fine, it's very reassuring to see the dashboard. You're like, oh, okay, that's cool. That looks normal. You know, you kind of get used to look at the dashboard, and every member of my team can just look at the TV, and in 5 seconds, they will tell you if everything is okay or if everything was okay during the last 4 hours. Well, if they see that, obviously something's not okay. So this is an example. I really like the overlay of the bar charts that pops up in the foreground when we send 500s. This we can definitely tell that something is not normal, and it's so visual. You have some kind of history. I think we are successful in the migration to from the monolith to service-oriented architecture. We currently have like hundreds of services, and every feature team owns one or multiple services. We have advantages with that. They have their independence in terms of release engineering. They can deploy whenever they want. They're basically completely independent, and this gives us a lot of flexibility and also more reliability. However, how do we ensure that they are monitoring the service like we are monitoring the infrastructure? What do they know about the infrastructure behind the service? Do they know which region are they running in? Do they know how many instances of their service are running? Do they know if they are serving 500s? Well, we don't know, and sometimes they don't either. This is why we've tried to fetch our experience from monitoring the infrastructure and the main Yelp app, like our monolith. And we try to spread the knowledge to them. So this is a dashboard that we put together recently. It is a cool dashboard because it's kind of a mix of the best dashboard we had to monitor our main site, but apply to every single service. The most important feature is that they get this for free. They just have to run a service on our platform as a service, and automatically we will generate a dashboard like that for them. We will customize the axis and the scale according to the capacity that they require. For instance, if their Docker container require 2 CPUs, the scale from 0 to 100% represents 2 CPUs, while if another microservice requires only half a CPU, 0 to 100% will be only half a CPU. So I'm gonna walk through this dashboard with you. Start top left, for instance, we just show how many requests per second in the 4 different active regions or data center. It's a stack chart. You can see that at this time of the day, we did a failover. We actually had a big outage, and we decided to run the entire website only on 2 regions instead of 4. We can see that the autoscaler mechanism works. This is the instance count, so they can see how many instances are running of their service, like how many Docker containers have we spawned up to make sure that we could deal with the load. Kind of similar to the previous dashboard, they have here 2 very important information for any REST-based service. They have the web timings, percentile 50 and 99, and that's the 2 lines, and they have this overlay bar chart of 500. So at this point, the service sent 500s, and it's very obvious when you look at the dashboard. You can tell, okay, something was wrong here. An example here, this is there is one line per container running, and this is representing the CPU usage of their container in blue, while the other line will represent the worker usage. So you always want to have some workers available when you're running a web service, because if you don't, then you will send up a 503 and basically you're not able to answer the call. Last, this is probably the deepest data that we have about this application. It's the usage per endpoint. So that means that the endpoint that actually in green on the screen is obviously the most important endpoint for this service. And you can see, for instance, if one of your region is read-write while the other are read-only, you can see some different colors here because some different endpoint usage in every region. So how do we build this dashboard? So we use SignalFX. The first phase is always the same. You just go on a website, you start a new chart, you select the metric that you want, and you start to poke around, change the color, change the filters, and yeah, you get something like what you can see on the left. That's cool. However, this is difficult to maintain. The more complex your dashboard becomes, the more team you have using the same dashboard, and when your data evolves, when the title of your metrics or your dimension change, it's very painful to update, especially if you have, like the previous dashboard, like a lot of charts. You have to go through all of them. It's not possible. So for that, SignalFX has a nice tool called SignalFlow. It's basically what you see on the left, but written in a code format. And that looks scary the first time you look at it, but in fact, when you get used to it, and for complex dashboard, it's much easier. And this is, you can do API calls and just send this syntax into it, and it just creates a dashboard for you. This is a very simple example of SignalFlow. You start by defining a filter. In this case, we want to see the service reservation for the production ecosystem, and we want to filter the rate over 1 minute window. So that's the filter that we define. The filter can be common to multiple line of metric, and then we actually asking for the metric that we want. So that's a Python pyramid app. We're using UWSGI, so we're asking for number of 200, so successful response, and we're just applying that request filter to it. Sum by region, published, and up you got your chart. A real example, that's literally the one that we saw earlier. The code is going to be a little bit difficult to read on the TV, but I'm just going to show you some blocks here. You got for the workers, you just define your filter, you count the number of busy, idle worker, and then you just calculate the percentage of busy workers. This is very straightforward. The blue line represents the main instance. You can see some like drops falling from the sky. This is actually the auto-scaling at work. You can see that the orange line was very close to the top, which is not good, and so the autoscaler of our system decided to pour more instances into production to go with the load. And yeah, so that's what you can see just by looking at this dashboard. Yellow line, I don't know if you see it well, but on the left we can see a little yellow, bright yellow line. So that's our canary. It's very nice to have a different color and a separate line for the canary, because when you push a new version, if the canary goes completely crazy, you know that something is wrong with your code. And it's easy to roll back one machine, one container. It's harder to roll back the entire prod. Finally, the last piece of code is to catch all the instances that are now main or canary. I will just display them in gray here because I know that they are not the most important information. So, but we still want to see them on the chart. So gray is like a nice color for that. So now I'm gonna do like a quick interlude and talk about something that we love in infrastructure at Yelp. It's Terraform. So what is Terraform? How many of you here have used Terraform? Okay, that's good. So Terraform is a way to describe your infrastructure as code. So this is super nice because I think the old way of doing things, we need to bring up some servers. How do we know, like 2 years later, like how many servers did we have, and how did we brought them up, and what kind of server they were, and why did we choose this? Well, in Terraform, kind of solve the issue because you just describe your entire infrastructure as code. And there is this thing called a provider that's gonna read your Terraform code and make the necessary API calls to, in that case, AWS, to create the infrastructure that you ask for. So this is a very simple example taken from their website. We just create a T2 micro instance based on this AMI, and that's it. That's you got your infrastructure. It's very clear what's in there. So we created SignalForm, which is a Terraform provider for Signalflow. So we said, how are we going to keep the integrity of our dashboard? How are we going to create an infinity of dashboard for an infinity of teams and services? Well, we just check it out in a Git repo, and we just describe all the dashboard that we want as code. And then we just have to do make apply on Terraform, and we instantly create 100 of dashboards. So yeah, this is pretty cool. This is the only way we could offer this dashboard for free to every team and every service owner. Here's a simple example of Terraform. So it's basically, of SignalForm. It's basically Terraform syntax. You can see that we can have a list variable that's a list of services. So for instance, the mobile reservation, and then we declare a resource, a Terraform resource called SignalForm time chart. And the second line, the count, is we define how many resources like that do we want. So there are 3 services. I want 3 charts like that. We give them a name, specify some parameters like the time scale, or if you want a stack chart. And in the program text field, this is the Signalflow request that we've seen earlier together. So yep, that's just how we do it. We just have to apply this, and we got our dashboards. If we need to do an update, then we just change one line of code, we apply, and all the dashboard get updated. Yeah, that's it. So if you have questions. I am part of operation team, same family as infrastructure team and the metrics team, but I am not part of the team who choose the vendor that we're going to use. But as far as I know, if we look a little bit back in the history, we did reinvent the wheel, and we did build our own metric system before. That was my first weeks. We had some very cool dashboards. They were very good looking. However, we found out that it was going to be difficult to scale and to maintain over time. Just twice a week. Yeah. Yeah, I mean, when you're working in a building with 500 developers, they're going to break things. And if they don't, you are going to break things. Like, that's what we do. We break things all the time, and the dashboard are a wonderful tool to see stuff that's not necessarily page, but should maybe. Or maybe it's like just a little anomaly, but yeah, twice a week. We have 2 dedicated teams to maintain what we call the Yelp Lib, which is basically a Python pyramid USG app that's constantly maintained with cool feature that a team can just opt in, and then they will build the app on that. So that is all those metrics have been. I think they're kind of they come by default with pyramid in USG. Especially if using the twins, but I'm not an expert on that. We have like a performance team and a core backend team that works all the time to provide those metrics and try to give them for free to every service owner. That's pretty cool. Yeah, it's a good incentive for us to, sometime they come to us. Not directly to operation, but to infrastructure, and they say, okay, we want to build this in Rust because Rust is cool. We want to do Go, or worse, we want to do Ruby. And we're like, okay, I mean, if you need to, just do it. But if you use Python, you will take advantage of all the experience that we built for years now, and you will have all this. Like this base repo where your apps run that gets updated by another team that's dedicated to that, and so yeah, that's pretty cool. That most of our services are using Python, and most of them will provide this set of metrics.